Wolf McNally. I'm the lead researcher for Blockchain Commons. This is the ZeWIF Zmigrate working group meeting of March 14th, 2025. We all have a collaborative document which won't be visible in this video, but we will post the link with the video so you can review the working product of the group. This is the group we have present. If we can just go around really quickly and introduce ourselves. Chris, would you begin?
Yeah, I'm Christopher Allen. I'm the principal architect at Blockchain Commons.
Okay, Chris Nutticombe.
I'm Chris Nutticombe. I'm a core engineer at ECC.
Okay. Paku.
Hi, I'm Paku. I'm working as developer relations engineer for Zcash community grants.
Okay. Zankas.
Hi, I'm Zonkas. I'm the coordinator at Zingo Labs.
Okay. Dario.
I am Dorian, a developer in Zingo Labs.
Okay. And Decentralized Dan.
Hey, I'm Decentralized Dan. I work at the Electrical Company.
Great. So if you wouldn't also mind adding your names and affiliations to the work in progress document in HackMD, that'd be great. I wanted to discover whether anybody feels like it would be useful to have let me make sure I have this on my screen. There it is. Whether anybody would like to needs a tour of my work so far in the Rust version of the Zmigrate. I've already announced it on the Signal working chat group, but I'm happy to take a high-level overview of it. But essentially, in a nutshell, I'm now parsing Zcash and Zingo wallets, but the goal is to actually have a set of abstractions which kind of transcends those and all other kind of wallet formats, whether you want to call it a wallet or in-memory dump or whatever. And as I say in the document, the goal is to not to create an operational wallet, but to create an interchange format. So thank you for adding your names to the list. So the goal of this meeting is to get input from all the variety of Zcash wallet format experts, and revise the proposed Rust abstractions, which are just a starting point currently. That will help me target the actual MVP of the deliverable of this grant, and identify any outstanding issues that we still feel need additional research outside this meeting. So, like I said, the people who see this video aren't necessarily going to have this document handy unless you open it. So please do look for the link in the video description and open the document so you can follow along and see where we go with this. So does anybody actually, would anybody actually like a tour of the Rust code as it stands now in my work, or do you feel like that you've already had a chance to review that?
I've already looked over this, and I made one set of comments, and it looks like you've taken some of them into account, and now I have more comments.
Yes, so that's actually, well, the Rust outline in the document is just essentially pseudocode. I'm actually referring to the Zmigrate crate, which obviously is not in crates.io yet, but is the body of Rust code I've been developing pursuant to this grant. That is actually it's actually a command line tool that both parses Zcash files as well as Zingo files, and then basically dumps to the terminal a debug representation of the contents of those files. It's the starting point, which I intend to refactor into a separate crate, which will be the hub for a set of front ends, which will read wallet formats, and a set of back ends, which will write a set of wallet formats, including a generic ZeWIF format, which is the Zcash wallet interchange format. The intent of that format is that it will not only capture all the most common information needed by wallets, but also the more esoteric or wallet-specific information as a set of attachments. The idea being that nothing should be lost, ideally. So when people might use this tool to back up their wallets, then theoretically everything is recoverable from them, either back to the original format or some other format should they need to move. So, like I said, I'm happy to give a high-level overview of that, or just but that may not be necessary for what we want to do right now, which is more or less define the higher level abstractions, because right now what I have is two separate Rust modules in my code base, one for Zcash, the other one for Zingo. the one for Zcash since Zcash is a mixed C++ and Rust code base, I created a set of de novo Rust structures to kind of capture that information without providing all the functionality, and then actually use the Berkeley DB DB dump tool. I invoke that from Rust and dump that text, and then I parse that as text. That was easier than finding a crate that actually parses BDB files, because that's not actually very easy to find, surprisingly. Whereas for Zingo, it's a monolithic binary format. I just read it from front to back using the same, more or less copy and pasted code from the ZingoLib crate, and which is not published on crates.io and has a lot of pin dependencies. So I had to duplicate some of those into my code base. I intend to refactor those out as we go. But so anyway, it's very much a work in progress. But the idea is, now that I've read these things, I can have them all in memory, and I can go back and forth. And I can see the dumps, and I can actually see that I'm reading these things. As a non-Zcash expert myself, coming into this as an outside expert from Blockchain Commons, I need this audience's help to figure out what is the most common things between them, and we can refer to the code I've done, or we can just refer to your own knowledge of what Zcash is and what its commonalities are across wallet formats, which is why I wanted a diverse group of people here. So
quick regarding that. I mean, clearly we have people from 2 current wallets, and then some experience with Zcash D,
Three
or extensive
current
experience. Yeah. So let's, if we can maybe quickly capture what wallets are kind of represented by team members here, that would also be
Chris,
useful.
you also had your hand up, so please jump in.
Yeah, could you add the link to the code base that has the tool in it to the document?
Yeah, one moment, I will do that. Go ahead. So if we would like to talk about the wallets that we're most familiar with, that'd be great.
Okay. So yeah, I have worked both on the Zcash D wallet and on the Zcash client backend and Zcash client SQLite wallet backends, which are used by Zashi, Edge, Nighthawk, and Unstoppable.
And I'm just putting into the chat the link to the Zmigrate code base.
Yeah.
Paku, do you want to talk about the wallet's domain expertise, your wallet domain expertise?
Yeah. Well, I've developed the mobile SDKs, like the initial ones, and maintained the reference wallet of ECC and architected the base of what it's known as Sashi today. And then I worked on wallets independently with Zingo, and I contribute now as an independent developer to any team that welcomes contributions, basically.
Great. I'm just going by the order on my screen. Zonkas?
I'm most familiar with the Zingo wallet, which I've been working with since we forked it from Zec wallet Lite. So that's probably important in this context. Is the modern version of that wallet.
Okay. Darian?
Mainly with ZingoLib and Zec wallet.
And Dan?
I do not have domain expertise here. Just more on the comms and community side, listening in.
That's great. I appreciate your participation as well.
So I started a quick little wallet section near the top. If people can fill that out, I'd be appreciative.
Okay. So yeah, there's so I see Christopher's added a wallets section along with the names of the wallets and the people who have the domain expertise there. Yeah, so basically, as I said, the document's collaborative. We're all working at the same time. I find that kind of experience to be working on a document with multiple people at the same time kind of magical to see how much gets added when we're all working together. So please don't hesitate to jump in and write what you think should be there. Um, and so just in terms of the actual code, Chris, Chris Notticombe, you had some comments. I did incorporate one of them. I didn't have time to do the others at the moment, but I really appreciate your comments. And you mentioned that the idea of having an accounts-based wallet might not be the best kind of starting point. Obviously, we're trying to create something that is, a superset of the kinds of data that are included in wallets. And so, if you care to talk about a little bit about what you think should be at the very highest level of the abstraction, that would be great.
Yeah. So I think accounts are a reasonable thing to focus around. The way that I'm defining account is essentially as a unified bucket of funds. And I think what you have here is a reasonable start, but there will be some more things that we need to add to make this all sort of hang together. So I'm gonna kind of as you say, collaboratively edit the document to add the things that I see that are sort of missing, and so the first thing
Yeah, and
is
if we're typing at the same time, don't worry about periods of silence in the video. Obviously, people who watch this will understand that we're editing sometimes here, and that's so we don't need to narrate the whole time. But please make your changes.
okay. So we're going to need a zip32 account ID potentially eh, associated with the account. The seed material is associated at a higher level. And then we're going to also need a transparent address struct. This is going to have the address thing. This is going to have, well, it's going to need to potentially store the spending key. So this could be, let's call this transparent spend authority. And this is going to be either a spending key, and we'll just that it's a byte array. This is proof key, and then or this could be essentially a derivation path, or this could be a child index.
Those is one step in the derivation path.
Yeah, so yeah, just the transparent. Well, actually, no, we need multiple things here. So the child index is going to have key scope, or this is going to be yeah. And this is going to be 32, and then child index is also 32. In general, those could be so the key scope, I can't remember. I think that is in the non-hardened space. I know that the child index, that this could be index, and then the key scope, I think, let me just double check. Bit 44. Okay, yeah, both the change and the change level path or path element and the address index are non-hardened. So now I have to find
The question, I've never quite got a good answer on this. It's become in the Bitcoin world, there's also like how the change is handled is different in some of the earlier wallets and has become more significant in some of the new descriptor wallets. I was wondering if there's, we have equivalent madness we need to puzzle out.
so the to the best of my knowledge, with well, we'll just call this H. Yeah, something like that. Derivation info is a good name for it. So the change index just says internal, external, or in the case of Zcash with text addresses ephemeral. So we have a third scope that is that we use for addresses that are essentially intended to be one-time use addresses. And we didn't want those to collide with indices that might come from a fully transparent wallet, like a ledger or something like that, because they do external scope addresses for those that you share and internal or change scope addresses for those that that it generates for its own change outputs.
Sorry, is that a text style ephemeral?
Yeah, so
Okay.
yeah, we have, again, three, what we call them are key scopes in Zcash client backend, or Zcash keys. There's external, internal, and then ephemeral.
Can we because those persist on chain, I find the ephemeral naming convention in that case to be problematic.
Yeah, it's a name. Naming's hard.
I agree.
The essential idea there is that these are intended for one-time use, but they may receive funds. Because the use case that we were given was that if an exchange wanted to reject a deposit, then they'd be able to send those funds back to the originating address. And that's why they wanted a fully transparent step, essentially at the end of the chain. So the way that Zashi handles outputs to text addresses is all of the funds in Zashi are stored shielded. We create two transactions, one that de-shields, and then a second that sends from the de-shielded value in a zeroconf transaction to the ultimate receiver address, transparent address. So that there's a fully transparent hop there. And we only ever use such an ephemeral address once from within the wallet, but if funds are rejected, then the wallet needs to be able to detect them and reshield them.
I don't know if it's going to come up in the scope of this document, maybe, but if we do need to represent that, text style, I thought maybe refund address would be a good name for wallet interchange format. Does that require special representation at the
No, it just basically comes down to, at the change level, it's going to be a specific non-hardened child index of 2 instead of 0 or 1, which are the
okay. All right.
internal. So this what I've laid out here already encompasses that, I think.
Yeah, and I'm trying to recall from the early days of Zec Wallet, did they have the pools of pre-generated keys to take change, as I think Christopher was alluding to, or not? Because if we do need to represent that style of transparent spend authority, I'm not sure if it fits well into the enum that is sort of expecting the HD derivation style of key interrelationship.
Like, can you repeat that? I'm like, I didn't follow.
The bag of keys model, but before
Yeah.
HD derivation was a thing.
Yeah.
If I don't know, so I don't recall if those were used in Zec Wallet or early versions of Zcash D. I think they were. I know,
Yeah,
you
definitely
know,
Zcash D has the bag of keys model.
Is
okay,
the
so
relevance of that whether we need that at like the highest level of the abstraction here to have an option to include a bag of generated keys, or
yeah, I think we probably do.
So
Okay.
so what I'm attempting here is actually that. So by adding, I'm just gonna change this around a little bit. I guess we have that's optional. What spending authority is, and then all right, I think that that kind of correctly captures things because we have a bag of addresses. Each transparent address has some spending authority or potentially some spending authority associated with it. Either we have either we know the spending key or here, I'll rename this to spending key. Either we know the spending key or we know that it's derived, and if the spending authority is derived and we have the derivation info, then we can obviously get that from the seed at the level of the wallet. Now, interchange wallet, this is also probably not quite sufficient because this we'll need one higher level structure, which is essentially just a wrapper around a vector of these wallets, because you can have multiple seeds in some wallets.
Okay, so so a single wallet file, you're saying we can have multiple of these, what we're currently calling interchange wallets within it. Is that correct?
Yes.
All right. And I'm not going to name it at this moment, but
yeah.
I guess I'm a little. We were talking accounts, and then all of a sudden, accounts became wallet, and
well,
I've always assumed wallets can have
jumping around.
multiple accounts.
Yeah.
I
Well,
just want to be sure that we're really clear on.
Yep. Yeah. So an account in general is considered just a bag of funds that are treated as a uniform pool of funds. So for example, the Zcash D wallet, at the time of launch, the transparent funds all belonged to a single pool of funds, and there was no differentiation according to address, even though you might have, and you did have, dozens or hundreds of different addresses that had been allocated. They
but
were
their
just sort of
UTXOs were all available to be used in new transactions, essentially.
exactly. So any new transaction could just select arbitrarily from those UTXOs that were associated with those addresses. Then at the time that we introduced HD derivation in Zcash D470, we changed things somewhat so that now the Zcash D wallet is built around the notion of accounts that correspond to zip32 HD derived accounts. Each account may have, a shield, as a bag of funds, it may have some shielded fund UTXOs in it, may have some transparent UTXOs in it, but they are treated more or less uniformly in terms of a single balance from the perspective of the wallet. In making that transition, we then said, okay, we still need the existing APIs that treat the wallet as having a single pool of transparent funds that are allocated by get, or where you allocate new addresses there by a get new address. We still need to. We want to make those addresses recoverable from a seed, but and we want them to be treated as part of that, bag of funds, that pool of funds. And so we allocated the maximum valid zip32 or BIP44 account level identifier to correspond to those semantics within the wallet. So within the sort of main account, call it, of a Zcash D wallet, you may have, you know, some keys that are generated from system randomness. So some addresses where their spending keys are generated from system randomness, and other spending keys where they are derived from that maximum zip32 account under the seed, and that's all treated as a single pool of funds.
So the what I'm calling interchange wallet right now, I mean, obviously, and then which has multiple accounts. Again, obviously, I don't want to bike shit about naming things, but names are important because they're, we'd like to make this self-documenting. But would the top level structure that I'm currently calling X actually be the what we want to call the interchange wallet, and the thing below it be something else? Because again, I'm thinking of wallet in terms of everything inside a wallet.dat or similar file, essentially something that a user would consider monolithic when taking their Zcash assets and backing them up or moving them into a different client or other environment.
So okay, that unfortunately, in dealing with the Zcash D wallet specifically, what we're facing is the fact that we have this history, right? And we want to maintain the semantics of the distinct pools of funds within that. So the distinct pools of funds are each an account. So I think that that currently makes sense. The only thing that this doesn't account for is the potential to have more than one seed within a wallet structure. And that is something that is supported by, for example, the Zcash client backend wallets, is you can have multiple seeds, you have multiple accounts underneath each seed, and then multiple addresses under each account.
And that's all within one of the
one
files.
wallet database file.
Okay, all right, yeah, and yeah, so so if we renamed X here, for example, like wallet DB, just so there's basically we're talking about a higher level abstraction like that, which contains a set of interchange wallets. We could just even abbreviate that wallet for brevity's sake, and then a wallet can contain multiple accounts. Now the question is, when you consider Zingo and so on, does this also encompass what Zingo does, even if Zingo doesn't use all these abstractions? The question is this a superset or not? Does anybody care to weigh in on that?
I don't know exactly. Oh, go ahead, Za.
I think certainly from the WalletDB wallet seed material, again, I have a concern about the BIP39 mnemonic variant name because there's more than one kind of mnemonic. And then so I think
you mentioned another. I think you mentioned, or somebody mentioned another variant of mnemonics. So we can add a variant to that enum pretty easily.
The ERP one.
Yeah.
Right. That's coming from Zcash, like Chris.
The HDC
recovery phrase.
No, the ERP, but the ERP is not present at all in Zec Wallet.
No.
Okay, then I retract my concern about Zec Wallet and transfer it over to Zcash.
Yeah, so that's why I added the random seed material, because so in Zcash D, there are two possibilities. One is that you have a BIP39 mnemonic, and the other is that you have seed material that was used for sapling key derivation that was derived from system randomness, but that did not correspond to a BIP39 mnemonic phrase. And those are the only two options that I know of there.
Okay.
But you're deriving the seed phrase from the seed. You're deriving that mnemonic from the seed. Is it?
Okay, so that's something separate, and I think that is something that we hold on just a moment. Visitor.
Yeah, that's yeah.
I will be
we
back
have
in just 2 minutes. Let
no
me
problem.
finish my
We
sentence.
understand.
Yeah, no problem.
So what you're thinking of, Sa, is that we did make it possible for exclusively for backup purposes, for ease of backup, to translate that seed that was derived from system randomness to a non-conformant mnemonic phrase, just so that you would have something that you could write down. We don't want to, I don't think that we want to make that part of the interchange format. It might be like a serialization of the interchange format if we wanted it to, but I would rather just stick with, here are the seed bytes. If you have this other kind of mnemonic and need to restore from that kind of mnemonic, that can be the job of something else, but it's not really, since that's just an encoding. It's not the fundamental thing.
Yeah, I like that, because we have a similar type of thing where we have obviously BIP39, but we also have a different set of things we call byte words that some of the Bitcoin wallets are using. So it's a similar thing where it's not the responsibility of the interchange format to store the byte words or even the BIP39 words. It's to store the underlying values from it. So yeah, I think there is keeping a nice separation between encoding versus the raw material is probably a good.
Would that be part of an extension?
It might be, but obviously whenever a user uses a BIP39 mnemonic, they may, under certain circumstances want to be able to retrieve that mnemonic, in which case you don't want to, you probably do want to store, as is the seed material shows, the actual string. And then just derive the actual seed from that as necessary, because the mnemonic itself is the source of that.
Is necessary. Yeah, I was going to agree with Wolf on that. In BIP39, that's the case. However, with the ERP, there's the possibility of deriving the phrase, the byte word style perhaps phrase, from the seed. So going the other direction is available in that case.
Yeah.
And
I'm
so
still I'm sorry. I just wanted to say I'm still in the, kind of a thing of, we are going for, a minimum viable architecture here. And, I think that, storing in what we've been calling, an attachment, raw data of things like this is how it's how it was actually derived into a BIP39 seed phrase or into some alternative seed phrase and things of that nature. I think we can store those. But the definitive truth, which is the actual, binary bits of the seed, that is what we need to have well defined and is the true source of truth. If the BIP39 mnemonic was wrong, I've seen some things because Japanese mnemonics and BIP39 are kind of different than and such, but are part of the spec. And I've seen a number of people do those wrong, and they work fine in restoring within a single wallet. But in fact, when you try to use those Japanese seed words with another wallet, they didn't do it right. Whereas if we say that the true source of truth is the seed value, and I think there are other examples of encoding differences, So I think this is a pattern.
If the only thing in the actual
Well,
source wallet is in fact a BIP39 mnemonic, Japanese or any other language, and this includes this up to bring us to the maybe we should be including a language tag here, but then I'm not sure that it is the job of the interchange layer to actually translate that into a seed if the only thing it discovers inside a wallet is in fact the mnemonic. That's what should be preserved.
so there's two different in the ERP backup flow. The ultimate source of truth is the seed, but in a BIP39 mnemonic flow, the ultimate source of truth is the seed phrase. So they're different in those two flows.
Right, and I think we just need the flexibility to preserve whatever we find in a particular wallet format, because obviously right now, you know, the ones most closely under discussion are Zcash D and Zingo, but we want to support, you know, the effectively everybody. And I think that means that once we've read these things into memory, a backend written by a wallet developer or somebody in, you know, maybe in the open source community will examine these in-memory structures and then decide how to translate that to an output, you know, into the destination wallet format. And so, you know, we may facilitate that a number of ways, the interchange layer, but we're not trying to interpret what's in these files so much as we are trying to preserve them and bring them up to an abstract level. Again, these are my takes. Please feel free to disagree or, you know, add whatever your thoughts are on these. You know, I'm not speaking authoritatively here. I'm just giving my impressions.
I'd like to hear Chris's thoughts on that when he gets back, because he might not have heard some of this context. I guess I'm concerned that does this mean we need to have a, you know, binary flag that, you know, for this particular wallet export, this value is the source of truth? I mean, this, you know, remember the whole thing, Wolf, we went through with SSKR versus Slip32, where we discovered last minute that they were doing a different way of deriving the master key from it, which meant that it wouldn't round trip. And I'm kind of worried that you know, by not really being solid about where the source of truth is, then the kind of thing that happened with Slip32 could happen.
Yeah, I think the best we can do in this case is actually treat whatever we discover in the source wallet as the source of truth. If it's a string, then we, you know, and we recognize it as, say, BIP39, that's what we should be bringing in. And if it's just a binary string, like the pre-BIP39 string then that's what we should be bringing in. If it's both, then, you know, we can figure out a way of representing that, but that's still not something I think we should be interpreting at the interchange layer. You know, and obviously I definitely agree with you about what happened with BIP39 and why we chose not to endorse it at Blockchain Commons, but obviously we're stuck with it at this level to a certain degree.
Yeah. Anyhow, I was just, I mean, it could be that we need to have a flag of, you know, that this variant is the source of truth for this wallet. I don't know.
I think we probably need to consider that when we get there. So, okay. So, you know, if everybody here is let's see, Chris is still out? Okay. So, and by the way, thank you for sharing your screen, Christopher. I'm sure that's helpful for the people watching the video. So
I can hear you.
Okay.
I just had my parents stop by with some paperwork that I had to deal with really quickly.
Great, thank you, Chris. Yeah, so basically I just want to make sure that as far as we've taken this so far, this does look like a viable kind of superset to those present. And because, you know, obviously as we go through this, I'd like to drill down further to transactions and things that I want to kind of make sure we have the kind of highest level of abstraction. We're fairly confident. We don't need to be 100% confident at this point, but, you know, fairly confident. Because as I work on this, you know, by myself and with others here, maybe one-on-one, you know, we'll actually, you know, make this much more concrete as we go. But, you know, again, the idea here is to come up with a more or less a consensus that, yeah, this looks like this ought to work, and then we'll, I'm sure we'll meet certain challenges as we actually get into the implementation phase. So, I mean, obviously right now at the top of this file, we're more concerned with, addresses, and then, but as we get down into it, then we're talking about the various keys and what they're associated with. And then as we get down even further, then obviously transaction, and that's the big kahuna. So, obviously if anybody feels there's something we ought to be focusing on next, that's fine. Other than that, I mean, I'm happy to, if people are, have no obvious problems with what's above, I'd like to, get into the transaction details and to talk about whether or not this actually is fairly inclusive of what people expect to see in Zcash wallet transactions, or whether there's anything major that's being left out.
All right, I will be able to look at that with you in just a moment.
Sure.
All right, I'll be right back.
I believe in the original in Bitcoin, T address is transaction address. Is that what the T is in Bitcoin?
TXID or are you referring to the TXID
Yeah,
field?
well,
I don't know
that's.
of a T.
I thought that,
I don't know of a. Okay.
maybe there isn't one. I thought I remembered that T address was like a backronym to be compatible with a Bitcoin term that was the same term, T address. But maybe I'm incorrect about that.
I mean, there was some like T pubs and Y pubs and X pubs and all that kind of stuff, and pretty much everybody's kind of decided let's stop using those and use descriptors. Because that was another case of, kind of combining a encoding layer with a policy layer that caused lots of problems. So ultimately now everybody just puts the XPub in descriptors, and the descriptors say what the policy is, rather than having it be
in terms of how to derive addresses, essentially.
Yeah, well, I mean, like YPub was a clue that was in the encoding, weird way of enforcing it in the encoding format of an address. I mean, of a public key that basically told you that this was a not a legacy type 1. It was a different type of keys, and a different, and that just ultimately broke everybody, because there was like T pubs and Y pubs and Z pubs and different interpretations for that. So pretty much they've all moved to uh, um, descriptors, and now the latest descriptor stuff also has hints on how the change works, etc. So the word that I've been using for that family of stuff is policies. Like, what is the account policies? And I don't think there's an equivalent structure that we have for Zcash to sort of have here's the policies, including all the variants in a single account. But I think maybe the word is useful for us.
Okay.
That makes sense?
Yeah,
I
it
mean,
does.
I mean, obviously, at the point which Zcash diverged from Bitcoin, it sounds like there's a number of things like account descriptors and so on, which never got taken up by Zcash, which is fine as long as it's kept simple. Bitcoin has gotten much more complex.
Yeah, I don't think we have any of that. The Zcash, or at least the transparent part of the protocol, really ossified in 2016. So
I think that the language, I mean, if I was to say generically for the two blockchains, Bitcoin describes the policies of a particular set of accounts, or a particular account has a policy, and to maybe go to your earlier language where it's kind of a bag of accessible funds or whatever, if that's the definition for account, then there is, in in Bitcoin, that policy is described using a Bitcoin descriptor. And we may need something similar in an account to say, here is the account policy, which we need to describe. Oh, well, it's done slightly different in these 3 different ways. And, it can just be, A, B, and C, but that
Yeah, it's probably we don't
what
need
policy
anything
is
as
used.
complex as a Bitcoin account descriptor, right? We
Exactly.
can probably just use an enumerated type of these are the ways it's done currently, and deal with other things, ways that come up later. Chris, I noticed you were another comment.
Oh.
I noticed you were just editing the transaction, debating whether or not shielded spends should be sapling spends and so on. What was your
Yeah,
thoughts
so
on
there
that?
are it really depends upon how we want to represent some of these things. So some of the bits are common between sapling and orchard spends, but there are other bits in orchard actions specifically that are where I think we probably do want to represent orchard actions more directly than just trying to shoehorn them into the shielded spends and shielded outputs model, because there is a relationship between each paired spend and output, just like there is in the join
Sure.
splits in Sprout.
Yeah, you don't mix sapling and orchard in those VECs, right? So
Yeah, I think that we would like to avoid that kind of mixing. It would just
so would it
Chris,
make sense to combine the last 3 fields of what is currently in transaction, shielded spends, shielded outputs, and join split into an enumerated type for sapling and orchard, or some other like transparent sapling and orchard kind of thing?
I mean, what we might do is take what you have here for where it says shielded spends and shielded outputs. That stuff all looks like it is essentially the same as sapling. The with orchard, there are a few other pieces of spend and output data that need to be represented. Just so that you have it, I'm going to stick in here a link to the schema that we use to represent the wallet in Zashi and in all of the other mobile wallets that are supported by Zcash Client SQLite.
Okay.
I just want to be clear. Are we basically a single account, using our new definition of account, can have all 3 kinds of
Yes.
Okay.
So the various transactions in an account can be of any type, can be sapling, can be orchard, can be transparent. Those are basically the 3 basic options.
It's not even that it's at the transaction level. It's that a single transaction may have transparent components, sapling components, orchard components, and Sprout components, technically.
Okay. Well, does that mean that what's currently in transaction, in fact, if shielded spend data and shielded output data are kind of generic, they could represent any of those things? Does that
no, because so the specific fields that they're broken out into varies between the different protocols. So let me just paste this link into the doc here, and then I can sort of let's see. I'm just going to add this up in the wallet as
so you're actually adding this to the HackMD document?
Yeah, I've added it up at the top on line 20.
Okay.
So there's a link there now to how we structure a single wallet. Now you'll note that we don't have any seed or spending key data in the data structures that are defined in this file, because that's in the wallets that this is, we have separate key storage essentially.
All right, so this is the create instructions for the SQLite schema.
Yes, this is the SQLite schema. So the things that I was going to draw your attention to are, for example, the sapling received notes and orchard received notes um, uh, tables that are down on lines 215 and 288. So um, those are you can see that they're subtly different. Sapling has an RCM value, whereas orchard has row and R seed values. Apart from that, they're relatively similar. But it's and we also have like with transparent, we have internal and external scopes. An interesting piece here is that the internally scoped outputs don't correspond to any address. So those outputs, there is a protocol level address, but those addresses are intentionally never revealed to users. They're never displayed so that they can't accidentally have funds sent directly to them. They are the reason for that is a subtlety around how incoming viewing keys work. Or as opposed to full viewing keys. We wanted to make sure that if you had given out an incoming viewing key to some party, that party could only see value received and could not detect spends. In earlier versions of the stack, it was possible for someone with an incoming viewing key to detect spends because change was being sent back to an address that would be derived from potentially the incoming viewing key itself. And that then violated the incoming only property that we wanted to preserve. So those are
would you say that the schema you're outlining here, would you say that could become a model for our our interchange format in Rust?
I mean, yes, with some caveats. So the first caveat is that the schema is likely to evolve a bit because this is just the schema for the mobile wallet, which is intentionally sort of shielded first. That means that not all of what we might want to be representable as far as like the transparent bucket of funds stuff that we've been talking about is currently represented here, although it may not substantially need to change. It's just I haven't thought about it enough yet. I'm in the midst of that thinking process as we move away from the Zcash D wallet. But at least as far as the parts that are concerned specifically with sapling and orchard, then yes, this is a good model to go from.
Okay. And obviously I haven't had the time to really kind of examine it myself and so on, but in terms of the highest level abstraction of transaction here, starting at line 103 in the HackMD document, I'm not sure based on you showing us the schema whether or not this actually properly covers that, or whether we need to have other product or some types here to actually encompass the space here properly.
So what I would say with respect to the way that the transaction is laid out, something that should be sort of front and center of the transaction is just the raw bytes of the transaction. Everything else, the TX ins and TX outs and all of the rest of it, we already have effectively all of that is obtainable from the transaction.
You're obviously right, because the TXID essentially is, a hash of the actual bytes of the transaction. So that's unique.
Well, now there's a caveat here, which is that a wallet may store data that is not recoverable from the serialized transaction that is sent to the chain.
Right.
Because it's possible for wallets to, well, for starters, on the input side, you just have proof information. You don't necessarily have the output information referenced directly. But it's also possible to have constructed a transaction where you have sent an output and intentionally encrypted that output with a random key. And so your wallet can no longer recover it if that data is not maintained in the wallet database.
Right.
So I think that your transaction data structure here thus far is on the right track. Like I said, it just needs, like, the stuff that is currently shielded should probably just be sapling, and then there should be a separate section for orchard actions, is the way
Yeah.
that I would put that.
I'm gonna share my screen here just for a moment. Let's see here. Yeah, okay. So you should be seeing my VS Code screen with the wallet TX file open. So this is basically my read of the Zcash D wallet, based on the my parsing of it from the BDB files. And so this is actually based on three inherited structures. C wallet TX inherits from C Merkle TX, which inherits from C transaction. They're serialized in that order.
Yep.
And so this is the order I'm displaying them here. And obviously I'm trying to preserve every single thing about this. I don't see in this, and again, I don't claim to be any kind of expert, that the actual serialized transaction is actually stored here. It appears to be mostly the kind of higher level versions of this.
Yeah, so this is going to be purely the in-memory representation of this. If you look at the, so we, at least in the SQLite database, we also store the raw transaction bytes as they come off of the wire.
So I guess my question is, for example, if I'm thinking about an abstraction between this and the Zingo form of transaction and what you're describing, which is what is the union of these essentially. Now it sounds like that in this case, because Zcashd doesn't store the serialized form of the transaction in the Berkeley DB file, then that should be an optional thing in our abstraction, that if the serialized transaction is available, then that should be brought in. But that it's not a requirement. And obviously when parsing these things back out, if somebody wants, for a destination form, wants to grab that serialized transaction and then serialize that and just run that back out, they can do that. But more likely there's going to be this kind of more diverse set of fields here. If I go to my, let's close this, go to Zingo, there's a lot less files here. But if we look at the Zingo wall abstraction, it's got, actually been looking at this because this is the kind of the high level of Zingo. So maybe somebody's a Zingo expert can help me here, because I'm actually calling into ZingoLib itself to deserialize most of these things. If you look at my Zingo parser, it's actually the main parsing file is basically almost a copy and paste of the Zingo wallet, where I'm actually following the same logic throughout here, either calling directly into ZingoLib to read certain things like this, or in some certain very small cases, calling my own parse macro that actually parses something simple at the top here, but most of them rely on single lib. But even looking at this, I'm not sure where the transactions in the wallet live. Can somebody make that clear for me?
I think it was in log data. Let me check.
Chris, I have a question for you. Is maybe a better solution for this, which we will make which would be to make an exception from the rule that we're just basically capturing the data, not actually doing a cryptographic transform or whatever of data. That we should try and use the code for generating transaction form when it doesn't exist, because it's so important that we should basically document it well, but say when you're doing something from Zcash which does not store the transaction binary, here's the here is we do it in our.
Well, it may also be that we impose on front end, creators of front ends to this, that they must, as part of their in-memory representation, give us the serialized transaction format. In which case, right now we might take it upon ourselves to actually call into whatever part of Zcash serializes its own transaction, and then make that the primary.
Yeah, so the way this works inside of Zcash, the raw transaction data is not stored in the wallet DAT. The raw transaction data is stored in the block data, and then it's parsed into an in-memory index. So the raw transaction data is available for every transaction in the wallet when Zcash is running. And we access that directly. It's just not stored in the wallet DAT file.
Right.
Because it is recoverable from the.
Trying to get on it.
Yeah, so that basically again, that the main question I keep coming back to is, what's the high level abstraction that we should be guaranteeing we're providing, at this hub, in terms of the actual abstraction for
I'm just so what are the pros and cons, Chris, of basically saying we make a specific exception here that because Zcash does not store this, when we're importing a Zcash we have to create the transaction data as it generated the transaction data, because this format requires it, because we're indexing on it or whatever.
But the thing that I would try to focus on here is the most important thing that the wallet export format must be able to represent is any data that is not recoverable from the chain. So, because we can anticipate that any given Zcash wallet is going to have access to the chain in some fashion. They're going to be able to just take the TXID and request the specific raw transaction data that they're interested in from that data source. I think that I flagged the raw transaction data as something that we do store. It may be that for a wallet interchange format, that's maybe not entirely necessary. Where what is necessary in terms of the transaction data is basically the metadata, right? Who have I sent funds to, and what are the values of those funds that I potentially cannot recover from the chain?
That's a great point. Fundamentally, then what you're saying is that the most core piece of information we must store in our entry format is the transaction ID, because the blockchain itself is the source of truth. But beyond that, we need to figure out for each format, what is the most likely kinds of metadata that wouldn't be recoverable from that and store that.
Right.
I mean, speaking just for the case of Zcash-D, what would you say that would be in this case, and where would that be residing in the Zcash-D, Berkeley DB format that we can actually bring in and
So
keep?
that's going to be the let me think back about this carefully as far as what you've got here for shielded spend data. ZK proof is public information, so we don't actually necessarily need that on the spends, because that's recoverable from the that's recoverable from data on chain. The anchor and the nullifier are all things that are recoverable if you have the TXID and can grab the transaction data. The shielded output data, they're let's see, the ENC ciphertext is not sufficient because that's something that you may not be able to decrypt it. And so that's where on the shielded output side, you need to actually store the value and the recipient. And if you look at essentially, there's a sent notes table in that Zcash client SQLite link. The data that's in the sent notes table is the stuff that is definitely not recoverable from chain.
Okay.
Or definitely maybe not recoverable from, maybe not recoverable from chain.
Can you at least make some comments in this in the working document to that effect in terms of where that information is, so I can look up later? I understand it might be a bit tedious to put it all in right now, but yeah, that's the kind of input that's very valuable here. Is you're absolutely right. That anybody who's using the Zmigrate crate is either reading in the data, which means we need to record what's essential that's not recoverable from everybody else, or it's writing out, in which case it may need to go to the blockchain or other sources like historical price information, things like that we're definitely not going to be including, because that's all public record. But so is the blockchain. So I think that's a really important insight here. Is there's obviously things stored in these wallet files that is totally available on the blockchain, and we shouldn't necessarily prioritize making that exchangeable, because that's just something you can look up.
Right. I mean, but that's kind of what I say is the difference between, what is our 80/20 core MVA is that, all those things that are publicly available may not be easy to get, but are publicly available. And that data can be in things like attachments, and it's up to the importer to basically validate those against public data in case somebody tries to corrupt them or do things. But the essential aspects are those things that aren't in the public data, and indexes that are required for you to be able to get the public data, which might obviously it's a TXID, it's date and other different types of stuff.
Now,
So
go ahead, Chris.
Sorry, but yeah, I agree with like TXID and date and things that are public, but there's a lot of load on light clients that are trying to recover on-chain data. So there's a high cost in the Zcash system to decryption, doing trial decryption on limited resource devices. So if you're a light wallet and you can not be required to not just access the chain, but decrypt the chain in order to load a wallet, that there is some significant value there.
Well, so let me question that real quick. So one thing is if this is done on import, the fact that import might take 5 minutes or something of that nature is very different than the situation of, oh, you're only keeping the alighted data. So I would question that on that side, and then the sort of the second side is, we can define some of those things, but they aren't part of the core. I really would like to see, everything that that is private in a wallet is well defined in a well-defined ZWIF, ZWIF structure by the end of the month, so that with some work on the importer, they absolutely can recover everything that wallet represented that was private, and the rest from public, and then we can worry about the for ease of light clients and things of that nature, we may want to store some other representations and make them easily accessible. Brainstorm with me on that, Chris.
Yeah, so I was going to say the I don't think if what's costly in terms of the operation of the light wallets is trial decrypting every output. If you know which transactions specifically involve your wallet, then doing the retrieval of those transactions in a targeted fashion, modulo, privacy issues of leaking information to the light wallet D, then the cost of just decrypting the transactions that your wallet has already discovered that are for you is relatively minimal. Now, I agree, however, that from a privacy perspective, essentially, we should include the raw transaction data when we have it and when we can obtain it. If we don't have it, it's not a blocker. We just need the TXID. But if we have it, then we should include it, because then that helps preserve a user's privacy better on recovery.
Okay, so one of the other questions I had about the notes you made on the shielded output data is things like recipient address, value of the output. Now, the value of the output obviously is specific to the output, but is the recipient address more specific to the actual transaction, or because
No, that's specific to the output. You can have an arbitrary number of outputs to different recipients in a single transaction.
Okay. Right. So right, because for example, you have one change address and one destination address kind of thing.
Yeah, or I mean, for example, ZIP321 transactions, you can make a transaction that sends to 5 different people to split a meal tab or whatever, or or the reverse of splitting meal tab to pay a bunch of
right. So the outputs aren't really an aggregate; they're
whatever.
going to a place, or they're basically the set of how you're splitting up the inputs, essentially.
Yeah, each output is a fragment of the inputs, the input value.
All right. So so when we come back to the let's see, let me actually make sure my screen is shared here.
While you're doing that, Daria, where is she? Daria, Emma, can you briefly introduce yourself and also add yourself at the top in the shared document and in the wallet section? We did that at the beginning of the call, and welcome.
Yeah, welcome.
Your audio is not working, or your
I
was wondering whether you could hear me.
Yes.
Now we can hear you.
Now we can.
Okay. Right. I'm Dara Emma, R&D engineering manager. Yes, I will add myself to the document. Yeah, I was basically going to make the same points that Chris made about efficiency of scanning. And yes, the privacy thing is important as well. It would be kind of unfortunate if a user imported a wallet file and then immediately leaked all of the transactions that they were interested in.
By the way, I see you added the raw field, Chris, and that's great. I usually I don't know, maybe if there's might be bike shedding, but I tend to make it so that if that thing may not be present, I do enclose an option, even if
Oh, sure.
you could
I just wanted it, I just wanted
Sure.
the field in there. However you want to represent it is fine.
Sure. And in fact, yeah, I mean, just using my own set of abstractions, I'd call that a data because that's variable size. But yeah,
Okay.
so yeah. Okay. So yeah, and then basically, Daria and anybody else who showed up, we're basically kind of going through this file. We're basically looking at the abstractions that are here. We're kind of evaluating how these abstractions might comprise or fall short of a MVP for a set of in-memory structures that could be used as a bridge between various wallet formats. And a moment ago I was showing some of the code in the Zmigrate crate as it is. The link is in the chat. Will also be in the video notes when this goes up for the public. But we're basically looking, for any kind of input that basically says this is good or this needs more work. And obviously, because the next step is it's going to fall to me to go through the in-memory formats that I currently have for Zcashd and Zingo, and then translate them to these formats essentially. So we have, basically these in-memory formats, and I may actually tap some of you individually just to work with you directly on, okay, where are these things that I need to go find and what do I need to do to them to get them into these formats. But this is, I want to make sure there's some consensus on this higher level that, yeah, looks like this is going to work. So that's the main thing I'm asking for at this point. So, we basically kind of determined at this point that, we have a high level wallet DB, which can contain a vector of wallets, which again, not everybody will have more than one wallet in a file, but Zcashd can. Wallet itself can include various kinds of seed material, a set of accounts, which again, whether the account abstraction matters or not, every wallet will at least have one account, and a set of transactions. The seed material bit 39, which is obviously a string or some other kind of pre-bit 39 seed that was derived from randomness. At the account level, some kind of account name, which I suppose could be optional if an account abstraction and a wallet doesn't use a name. A zip32 account ID, and a set of addresses for that. An address being either a transparent address or shielded address. And then let's see. And again, the reason why I'm repeating this is so if I can tell it like a story, then I can understand it. And if I can't, then I probably have questions. Obviously, we have spending keys and derivation indexes. The transparent spending authority can be either, let's see, I'm not sure we've said either the derived from a child index or a spending key. The derivation info, I guess, I'm not sure if the derived needs a derivation info.
Yeah, so there's a
Okay.
relationship between those, that if the transparent spending authority is derived and you have the derivation information, then you can spend it. There are, as you know, in Bitcoin, there are watch-only addresses that are imported to a wallet. And really there probably should be like, well, because spend authority is optional, we might want to represent this actually as like spending authority being non-optional, but we could either have a spending key, have it be derived, or be not available or something like that.
No, this is interesting. There was one other thing, Chris, that when Wolf was explaining it, that I thought was maybe a not a clear distinction. So obviously we have wallet, and so some wallets only have one account, and we sort of said, what account means is like, these could have multiple objects inside it because they're considered kind of a unified bag of funds, and have one account balance for that whole bag of funds, et cetera. And I think different wallets have different approaches as to when they start supporting multiple accounts, how they divide things up or whatever. And so it feels like there are some things that, like seeds, which might be used by multiple accounts, or seeds that might be used, multiple seeds that might be used within a single account. That feels to me like a weird problem.
I don't know of any wallets that that take the approach of having multiple seeds correspond to a single account. So I'd be completely comfortable with not supporting that particular variation.
Agreed.
Interesting, because Bitcoin descriptors now you can have
Daria has something she wants
3
to say.
different.
I'm just going to switch from my phone to my desktop.
Thank you.
Anyhow, I was just saying Bitcoin D in recent versions, you can put multiple root keys in a descriptor. So they have this little prefix before the public key value that says, oh, well, this is actually a different master key and a different derivation for the first part of this. And that just, I mean, that's don't know if Zcash is ever going to move in that direction. But that's why I wanted to bring that up.
Yeah, I mean, like I said,
Can you hear me, by the way?
yes.
Yes.
Okay. Cool.
I think that there may be more than one spending authority per account just because of the legacy Zcash D random transparent spending key generation issue, but I don't see any. I don't want us to ever support a notion of account that involves multiple seeds, or if there is need for that in some wallet, then that is the sort of thing where I would use an annotation or something like that, where the annotation on each of the sort of protocol level accounts that we're talking about, or bag of funds level accounts, if there are multiple of those that or multiple wallets even in our in interchange wallets that belong to some single logical grouping, that's something that I would say you have to do by annotations. That's out of band for the primary protocol here.
And by the way, you can still see my screen. The way that I plan on handling in ZeWIF the kind of attachments idea is based on something that has been discussed with the ZeWIF group and between Blockchain Commons, is using the Gordian envelope format, which is a kind of it's a structured data format that is very kind of crypto friendly and privacy friendly. It's a binary format based on deterministic CBOR. But basically, we've also have within that, we have a specification for attachments. And so when these get actually serialized to the ZeWIF format, the ZeWIF backend or front end, that will serialize to envelopes. But within this, we will have something like
at kind of every level,
a vec of envelope. Yeah, exactly like that. And so basically that will be available in this, and so you'll compose an envelope, you according to our attachment standard, that which includes a URL to documentation of that particular extension and so on, and as well as who specified it, and then you'll be able to add that pretty much at every level that matters, and that will be just thrown in there along with everything else. So, and it'll just be preserved. So just I want to make sure the group understands that's basically how this will be approached.
Yeah, I think that that's exactly the right approach here. That we're going to go for the the 80 or 90% solution, and then there are definitely some examples of things that are just weird. For one of the weird things in Zcash history that hopefully won't have a significant impact on anyone. I know that early versions of ZeWIF Lite did, instead of doing address rotation for the sapling addresses by diversified addresses, they essentially generated a new account each time you generated a new address, or from a BIP39 or a BIP44 or a ZIP32 perspective. They generated a different account each time, which is awful because those people then could potentially have, you know, dozens of accounts that don't share a single source of funds. But for those examples, I'm content for for modern wallets to say, we don't support those old semantics. If you want to consolidate those funds, you have to do so yourself.
Right.
Yeah.
Right. And so, yeah. So anyway, we want to make sure that we preserve everything, either for archival purposes or translation purposes. And so people who add attachments, it will be on them to kind of document their attachments, but even our attachment format has a way of linking back to your documentation in it. So, we hope we'll see good uptake of that from the community. But yeah, so generally speaking, the transaction itself at the highest level, will also be serialized to, part of the envelope is a series of predicate object pairs, and again, I'm not going to get the details of wallet right now, but essentially it's a semantic triple set where you have a subject, which might be the transaction ID, and then a set of predicate object pairs, which are attributes of that ID, and so that's generally speaking how things will appear in the wallet format, but there'll also be a number of potentially non-zero number of attachment predicate object pairs, which will be these things. So that's the general strategy here, just for the information of the group.
I notice a difference between the schema here and what I think, excuse me, Zcash does. So it will keep track of which transactions are associated with particular accounts. So it's not a global set of transactions. So this schema here does not keep track of which transaction is relevant to which account.
I think that's actually in it's true. The wallet itself has a list of transactions rather than that being associated with the account. Is there any, thoughts on whether the list of transactions should be more associated with the account or more associated with what we're calling the wallet? Or is that something more at this level where we have a vector of wallets, each of which has their own set of transactions?
I'm not sure. It could be that that's redundant information, and what you should actually do is just look through all the transactions and see which ones spend from or send to an address associated with an account.
I have an opinion here. I think that you are right in putting the transactions at the top level, and now that we have another level above, we should just move it up to that upper level, and then any.
I'm sorry, what should we move to the upper level?
Oh, so right now transactions are associated with the wallet. I would associate them with the wallet DB in the current thing, because and if it's essentially let's call it a map from, or like a B-tree map from TXID to transaction, that will essentially solve all of the issues. It's in that respect, we're looking at essentially just a filtered slice of the chain data with some with additional metadata attached to each transaction, and I think that's a fine way to go about it.
Okay. Yeah, looks like Daria is making some changes there.
I think this was why we wanted to have this meeting with you guys, is exactly to understand these types of things.
Absolutely. Okay, so does that look correct to you, Chris?
Yeah.
In terms of, so a wallet DB is a set of wallets, but a unified set of transactions across all those wallets.
Because
there's no need to encode them more than once, right?
Well, there may be no need to, but just like in Zcash client SQLite, we keep the raw transaction data around and we break some of it out for efficiency of access. There's some important metadata, at least with respect to and this may not be information that we want to keep at. So okay, let me think about this a little bit more. Spend information, or rather, excuse me, not spend, but send information. This is the data that we've talked about before that is not recoverable from chain, because you may have used a policy, an OVK policy of none, right? That the data is not recoverable to your wallet, or it's not recoverable from chain by you.
So what I was saying before about transactions relevant to an account, I don't know whether we want to do this, but editing this.
Yeah, something like that.
That's basically what Libra Zcash does, I think.
Yeah, I think the other thing. So I'm just gonna also spitball here and say, sent outputs or something like that.
Let me just look at the DB file. Remind myself of the schema. Oh, that's interesting. If you look at the transactions table, it includes the mined height. Now, that's interesting because if you think about it, because the blockchain is only eventually consistent, it could be that if you export a wallet at a particular point in time, and then there's a rollback, and that transaction is unmined or gets remined, then that information that was in the wallet database does not correspond to the current chain.
Yeah,
does that matter?
The source of truth.
I think
the point is to determine what the wallet thought was the truth at the time of the export, which may relate to other things it's storing in its database, and so it might, I'm not sure, not be possible to understand the database completely without understanding what it saw the chain to be at the time of the export.
So, that brings up okay, I have two thoughts here. I think that you're correct in I think that the mined height may not belong in the wallet interchange format, except insofar as it may be necessary for to avoid, as we've discussed before, leaking information by going and looking it up. The other thing that I just realized is not represented in this data format, but that is important, is the witnesses.
Yes.
Because the witnesses are expensive.
Yeah, that's critical.
And
are we looking at the transaction?
Those are going to be at a received output level. So this is going to be somewhere in here, as like
it's a sequence of hash values, right? Let me just look how it's represented. We've also got all of the information about checkpoints, which is, yeah. Is that actually needed?
Okay.
So I don't think we need to represent.
Not.
Yeah, we don't need to represent enough information to roll back the witnesses because we're assuming. Oh, that's a good point. So you export a wallet file, and then there's a rollback before that point. So now the witnesses are useless. Do we actually want to store the witnesses so prior to that point, past any realistic rollback depth?
Well, there's a problem with computing that both in Zcash and in Zashi at least, which is that once they're past the rollback depth, we discard witness data. And in Zashi, we keep everything, all of the witness data in a single data structure. Now, from that, so there may be, in Zashi in particular, or rather all of the Zcash client backend based wallets, where we're using shard tree, the witnesses may even be incomplete. You may not, at the time of export, you may not have complete witness data for a
yeah, there's a bunch of optimizations which interfere with sort of saving the witness data in
I think that
a simple format.
like, it's going to be something like this.
Sorry, where are you at?
It's line 179.
Yeah, okay.
Yeah, something along those lines, where the wallet must store the note commitment tree. Even that, well, yeah, I guess that could also change.
Yeah, it could be remind.
Could be remind. Yeah, all of that data could be invalidated by an export.
This is why I think
what we should probably
have to.
Do, okay, what we should
we have to.
Okay, Dara, Emma, I have a suggestion.
Yes.
Those we will make optimistic values, and we'll just say that they're stored as of
right. Yeah, we could do that.
So this will be an option because we might not have it. Our 20 blocks back from the chain tip. I'm like,
that's exactly what I was going to suggest.
Yeah.
we think very much alike.
So then we'll have to store one. If you're unfortunate,
so we simulate a we simulate a rollback of 20 blocks and say what the witness would have been if we have it at that.
We don't even have to simulate it. Both Zcash and both the Zcash wallet. So Zcash wallet contains all of the witnesses explicitly, right? Except for Orchard, where it's all stored in bridge tree. Yeah.
Okay, I see it. I see an issue here. What if this witness or this note is less than 20 blocks of age?
So I have a meta question here. Is this maybe more in the 20 of an 80-20 right now and should just now in one of the attachments, or?
Well, I'm not sure.
The problem is it's extremely expensive to recompute all of the witnesses. I'm not sure we even have enough information to do it.
No, we do, because so if so for example with shard tree, it's not that expensive because you have to just compute the contents of a single shard.
No, I'm saying if we didn't have these two fields, would we have sufficient information to recompute the witnesses?
You would have to find,
because we wouldn't know which height.
You would have to go
transaction
via
set.
the transaction. You would have to look up the block height and then figure things out from there. I mean, you could get
But
it.
that's we agreed to prioritize data that could not be reconstructed off chain earlier, right?
Right, but the
So
point is,
expensive.
if you have to do a full scan to figure out where the transaction is in the blockchain, then
But we agree that that's
extremely
bad.
expensive.
Before you joined the call, we discussed the relative merits, and I think Christopher has kind of persuaded us to focus only on that data. Chris and Christopher, the Chris's, got together and persuaded us to focus only on that data which we could, or not to focus only on, but to prioritize that data which could not be reconstructed. And then for data which, even in the case that it's quite expensive, or there's memory leak in the case of a trade-off with a targeted reacquisition, that data could maybe be more conveniently represented with extensions. I think that was what we agreed
Obviously, yeah,
earlier.
for
Okay.
an MVP, we want to actually represent mostly the data that we find in the wallets that we're importing that pretty much everybody wants. And then data that can be, but obviously, everything in the transaction can be recovered from the transaction ID. Not everything stored in the wallet about the transaction can be recovered in the transaction ID. So we definitely need to prioritize that. And then, but I do see, that it may not be our MVP, but it may be as, kind of an extension to, derive certain kinds of data or make certain kinds of data available that might not be available in every wallet, but that a lot of output formats might want, or at least, rather than put that on every single output format that might want that, kind of, again, forming a bridge of just doing that ourselves, storing that so that everybody has access to it on the output side. So this is, I'm not sure it hurts anything to put it in right now, but we might want to consider either making things attachments or deferring specific fields to later, as I mean, it's not a bad thing to put them in provisionally right now and just talk about what might be useful. We can do more triage later.
Well, hold on.
But hang on. So there's the privacy issue that was raised before, that if just after importing a file, what you do is go look up all of the transactions you're interested in, that's leaking a lot of information. Also, the schema that we currently have does include a lot of stuff from the chain. So I don't have a clear idea of what we're including and what we're not, because it's including the transactions, not just the TXIDs. So if walletdb.transactions was just a set of TXID, then that would be emitting data that can be reconstructed from the chain. As it is now, we're clearly including information that we could reconstruct. So what is the criteria?
I just want to be clear. I think what we were saying before is, there are certain things like, the exact transaction data, which you can theoretically go get from a server. That there are certain things we do want to include, and maybe one of the things, given this particular set of things, we want to include the block height, even though we could find that another way. But they're not, sources of truth. They might still be in the 80, not the 20. But then some of the details, if a wallet has it, they put it in those attachments as details. If it's but certain important things that would be, like you said, might require
So I
think if you look at the shape of the types of the transmit, what we currently have a transaction, it's pretty fair to say that transaction ID is the only one we can't omit, whereas everything else is either optional or a vector, which could be empty. So so based on this being an interchange structure, first and foremost, if we have this information, we read it in. And if we don't, then obviously it's omitted, and what we have left is what's the transaction ID. That's the absolute minimum. Chris, you have your hand up?
So I was gonna actually recommend something along those lines, which is we should define a schema for what is the minimum required data for a wallet interchange, which, so assume a local source of chain data. This meeting is getting long at this point. So
yeah, well, I intended to have it go 2 hours. I know it was a long meeting, and I appreciate everybody who's sticking through it. But yeah, I want to call it a close at the hour.
Yeah, but my recommendation, now that we've been through a bunch of this, is let's focus on defining a wallet interchange format that is exclusively assuming it's a local source of chain data, the information needed to ensure that all of the wallet's notes are spendable, and that any data that is not recoverable from the chain is preserved. And if we start with that, then it's easy to add on to that in a sensible fashion.
I agree. I agree that we should separate the data that's not recoverable from the data that is recoverable and is being stored as an optimization or that needs to be checked against the chain. What I was going to say is it's not the case that just because you have a vector, you can tell the difference between, for example, inputs missing or
Sure.
there are no inputs for this transaction. So
well, that's
if you want to represent
vector,
that, it will be option vec. Yeah.
Yeah, and I'm fine with totally adding option vec. I get the semantic difference, and yeah. I'm totally fine with that. And vec envelope for attachments can actually be just a vec because, you know, basically no attachments means no attachments.
Yep. Agree. Just something that I often do myself. Are you familiar with the non-empty type? Non-empty is a Rust type that is.
I'm not in the habit of using it, but I have heard of it. Yeah.
Yeah. So we in situations where we want to make that distinction, we often use an option of non-empty rather than an option of vec, because then you don't have two representations of empty.
Yeah, I get that. That's actually a good idea. And we don't need to make that change right now. I'll take that on board as I actually implement this. And I think that's a good idea.
It might actually not be applicable here because you might know that you have no inputs, for example.
For like a Coinbase.
So the current representation is probably correct. It just occurred to me as for anything where something's known to be non-empty, we try.
Yeah, I guess you'd have no inputs if you have a Coinbase transaction. You'd have no outputs if you have a burn transaction. I presume.
It's valid. Yeah, it's valid for transactions have no outputs.
Send everything to.
Yeah. So I see that using shielded spend data and shielded output data for both sapling and orchard with a to-do for actions. Does that actually work? I thought there were different fields for sapling and orchard.
We talked about this earlier before you joined the call. I recommended that those things that are currently labeled shielded just be sapling specific, and that orchard.
I agree.
Separately.
And by the way, even after we end this at the hour in 9 minutes, I would love it if you guys would continue to work on the document as the impulse strikes you, because I'm not going to lock it down at least within 24 hours and start implementing. So please continue to make clarifications and enhancements to it that take on board your best judgment. Don't worry about the group not having seen it or vetted it or whatever. This is I'm expecting that all of us who care will be reviewing the document repeatedly and then discussing with each other. So, make whatever changes you feel are actually, the most correct and most useful.
So it sounds like, in our last couple of minutes, first I want to appreciate everybody for being here, in particular the ECC folks, because I think that gave us the requisite variety that we really needed to come up with some of this. So thank you very, very much. I think this was also very productive. But I think, Wolf does need to process some of this. So the question is, do any of you want to maybe schedule a call directly with Wolf at some point in the future? Or
what I thought I'd do is after I review this, I'll come up with some questions and actually reach out to a few people, because obviously I'm really grateful for all your input, but we have your kind of mini resume and areas of top, and I may just ask questions on the ZeWIF list and just see whoever answers it. But yeah, but I mean, obviously, I think there's also probably going to be a couple times when I reach out and say, hey, can we schedule either a quick Zoom call or maybe a longer Zoom call where we go over several things that I don't understand or need to know how to do right yet, and just need your support. But I presume at least those present will make yourself reasonably available for that. So I'm happy to work that out on a case-by-case basis.
Yeah, happy to anytime.
Are there any other people that are missing from this call that we should maybe, when we have a next iteration for review, we should evangelize to join us?
Yeah, so we should definitely get Strad's input when we have a proposal, because he will see things that none of us have seen, as he is. I don't think I've ever submitted a pull request that he didn't have a comment on. But and then also shop it to Han. Han may be totally unresponsive. That's the lead developer of YWallet, or he may be interested. I can never tell. He's a productive but not very collaborative member of our community.
So we'll have this video up in its raw form for you guys, but as we do with all of our meetings, we'll have an edited version with some notes and all that kind of stuff. If you haven't seen our meeting page for our previous Zcash meetings, it's just developer blockchain commons.com/meetings. You can see them in there, and we'll probably have that up on Tuesday. And we can share that URL with the meta commentary with whoever else we need.
Yeah, I'd like to, while we're still recording, I'd like to reiterate that Andrew Arnott from the Zcash wallet and Hazel from Zingo both probably would have input as well.
Great.
Excellent. Well, we'll make sure that everybody has access to this video and access to the file. And again, I consider the file to be open until we're all pretty happy with it. And that I hope that will be probably through Monday or Tuesday or whatever, we're actively reviewing this and editing it and showing it to others and going over it, because I want to make sure there's a pretty strong consensus. And if you're not sure, put a comment in the file, and we'll continue reviewing it. Or it can be either an inline comment in the actual code, or it can be a comment using the HackMD comment feature. So I will be reviewing all that. Yeah, I mean, we're getting close to the hour, so I guess we'll start drawing it to a close. Any final questions or comments? And just thank you very much.
If we're pretty sure that a change is correct, should we just make it and
Yes, absolutely. I would say that
right.
because this is a and of course as we review this, if there's any questions about it, well you can see who made there's a blame feature basically, so we can see who made the edits. But yeah, I mean absolutely. If you feel something makes something better, fix it. And and of course the starting point for this was my wild ass guess. So everything is an improvement as far as I'm concerned that you guys make.
One more question. Where is the documentation for the type language that we're using here, or is it just pseudo Rust?
It's pseudo Rust essentially. So I'm saying basically use this as pseudocode, but just the only two things that in my own code base I use the parameter type blob as a fixed size binary object and data as a variable size binary object. Because I have some niceties about how they're printed and operated on in my code base. But yeah, other than that, don't treat this as having to compile. I will make sure.
Okay. And if I want basically an array of a fixed size, I should just use a Rust array. Right?
Yeah, just use a Rust array.
That's the blob type.
Well, that's a binary blob type. If you want an array of other types of a fixed size, sure, just use the fixed size array.
Cool. We'll do.
Syntax of Rust.
Yeah, I'm thinking of things like the nullifiers and the join split data. Okay.
Yeah, well, absolutely.
You'll see those are specified as blob of 32. So think of blob as just a Rust array with
No, I know that. It's
Yeah.
What I want is that that there are always two blobs.
Yes, if
It's
there's
not
always
that-
two
it's
blobs
not that
of
bad.
that like
Yeah.
that, then that should be
Oh, yeah.
yeah, absolutely.
Cool. Right. Yeah. I'll have a look at that then. Thank you.
Excellent. Yeah, thank you very much.
Thank you so much. For
I'm,
putting this
I'm sorry for
together.
being late.
Yeah,
No problem.
Thank
Understand.
that's
you.
fine. Yeah,
Well,
thank you
for
everybody.
joining.
And yeah, and the document, the meeting is closing, but the document is definitely still open. So thank you for your contributions, and I'll be checking it throughout the day.